The story begins on a cold morning in late 1944. Somewhere on the outskirts of a captured airfield in Europe, a group of German engineers stand silently around a massive, battered American fighter. The aircraft's olive drab skin is torn and scorched, its propeller bent, its canopy cracked. Yet even in ruin, it radiates something intimidating, raw, unapologetic power. The men circle it like archaeologists around a newly discovered beast. They don't speak much at first. They simply look, tracing the lines of the fuselage, the thickness of the armor, the enormous radial engine sitting like a clenched fist at the nose. And finally, one of them mutters quietly, "Donnerkiel, what kind of machine is this?" They had captured their first Republic P-47 Thunderbolt. To the Allies, it was simply the Jug, short for Juggernaut, a name that fit perfectly. It was big, loud, and utterly indestructible. To the Germans, it was an enigma. They had seen it dominate the skies, dive through flak like it didn't exist, and pull out of vertical dives that would have torn most fighters apart. But now, for the first time, they had one in their hands. And what they found when they tore it apart would leave even the proudest engineers of the Reich stunned. But before we get to that moment, before the dissection of the beast, we need to understand where this monster came from and why it was so unlike anything else flying in World War II. The Thunderbolt story begins long before it earned its fearsome reputation. Back in 1939, when the U.S. Army Air Corps asked for a new high-altitude interceptor, the engineers at Republic Aviation were already dreaming bigger than anyone else. Led by a man named Alexander Kartveli, a brilliant designer who had fled Europe to escape the chaos of war, they weren't thinking small, sleek, or elegant. They were thinking power. Kartveli didn't want a delicate bird that could out-twist its opponent. He wanted a flying tank, a machine so tough that it could take punishment, hit back harder, and still make it home. To him, survival meant firepower and durability, not grace. At the time, most fighters weighed around 5,000 to 6,000 pounds. Kartveli's prototype was nearly twice that. It was enormous, heavy, and when the first mock-ups rolled out, even American pilots laughed. Some said it looked more like a bomber than a fighter. Others doubted it would even get off the ground. But Kartveli had something special planned for at heart, an engine that would change everything. The Pratt and Whitney R 2800 double Wasp. 18 cylinders, air-cooled, and built like a tank, it was capable of producing over 2,000 horsepower. Later versions, even more. It was the same power plant that would drive the legendary Corsair and the Hellcat, but in the P-47, it became something else entirely. Because Kartveli didn't just bolt it on, he built the entire airplane around it. To make that much power usable, the Thunderbolt needed something revolutionary. A turbo-supercharger system the size of a small car. Instead of sitting in front of the engine, it was buried deep in the fuselage, with a complex web of ducts running from the engine to back of the plane and back again. This kept the engine fed with compressed, cooled air, allowing the Jug to fight at altitudes over 30,000 feet without losing breath. It was engineering insanity, but it worked. When the first P-47s reached squadrons in 1942, pilots were shocked by its performance. Yes, it was heavy, and yes, it could feel sluggish compared to nimble planes like the Spitfire or Bf-109. But once it got moving, the Thunderbolt could dive faster than anything else in the sky. Pilots had felt like riding a brick dropped from heaven, except this brick could pull out, climb back up, and come roaring down again with 8.50 caliber machine guns blazing. Each wing carried 4 of those heavy Brownings, spewing out a combined rate of fire so dense that a single burst could shred an enemy fighter or rip apart a locomotive. And when it came to ground attack, well, there was nothing quite like AP-47 screaming down on a German column, guns flashing, bombs dropping, rockets tearing through tanks. The Luftwaffe quickly learned to respect the Jug. Its armor was thick, its engine nearly indestructible, and its pilots loved it because it brought them home even when it shouldn't have. Stories began to spread of Thunderbolts limping back with holes the size of basketballs in their wings, oil leaking, control cables half severed, and still landing safely. But what the Germans couldn't understand was how. Their own fighters, the sleek Messerschmitt Bf-109s and Focke-Wulf 190s, were fast and elegant, designed for performance and agility. but they were also delicate. One solid burst from a .50 caliber could bring them down. Yet here was this brute of an American machine, shrugging off hits that would have torn a Luftwaffe plane apart. And so, when the opportunity finally came to get their hands on a Thunderbolt, the German engineers seized it with both curiosity and disbelief. Sometime in 1944, after a damaged P-47 made a forced landing behind enemy lines, it was captured mostly intact. The Luftwaffe's technical experts quickly transported it to a testing facility. Some sources point to Rechlin, the German equivalent of a top-secret aeronautical research center. There, engineers began the task of taking the American beast apart piece by piece. What they found inside would challenge nearly everything they thought they knew about aircraft design. The first shock came from the sheer scale of the internal systems. Every component, from the hydraulic lines to the cooling ducts, was overbuilt. The turbo-supercharger plumbing, a maze of pipes running along the fuselage, looked like something from an industrial factory rather than a fighter. The German teams, used to tight, efficient packaging, were stunned by the American approach. It was as if the designers had said, "We don't care about weight, just make it strong." And yet, somehow, the Thunderbolt's performance proved that this philosophy worked. They noted how the fuselage structure was reinforced to handle the stress of high-speed dives. They studied the massive engine mounts designed to absorb recoil from 8 heavy machine guns firing at once. And when they inspected the armor protection around the pilot, including the bulletproof glass and armored seat, they realized that the P-47 wasn't just fast and powerful. It was practically invulnerable. For German engineers raised on precision and minimalism, this was almost sacrilegious. But it was also brilliant, because beneath all that bulk and brute force lay a kind of genius, the American industrial genius of redundancy, reliability, and raw horsepower. And soon, word began to spread across the Luftwaffe's technical branches. The Thunderbolt is unlike anything we built. It's a machine that trades elegance for unstoppable force. But what they hadn't yet realized, what would truly astonish them when they started testing its systems, was just how much hidden power was still waiting inside that battered airframe. When the German engineers finally began testing the Thunderbolt systems, it wasn't just a technical study. It became an obsession. They wanted to understand how this massive fighter, which by all logic should have been too heavy to be agile, could still outdive, outclimb, and sometimes even outfight their best aircraft. The first thing they focused on was the heart of the beast, the Pratt and Whitney R-2800 double Wasp. It wasn't just big, it was beautifully over-engineered. The Germans admired precision craftsmanship, but the Americans had taken practicality to another level. Each of the engine's 18 cylinders was built to withstand absurd amounts of heat and pressure. The cooling fins were thick, the tolerances forgiving, and everything about it screamed durability. When the engineers started up under controlled conditions, the deep, rolling growl of the double Wasp filled the hangar. It wasn't the high-pitched whine of a Daimler-Benz or Junkers engine. This was thunder, raw and heavy. Even at idle, the vibration shook the walls. As one observer reportedly remarked, "This engine sounds like it could run forever." Then came the turbo-supercharger system, the part that truly baffled them. To German designers, turbocharging a fighter aircraft was practically madness. Their own high-altitude fighters used mechanically driven superchargers, simpler, lighter, and efficient. But the Americans had gone a completely different route. In the Thunderbolt, exhaust gases from the engine were piped all the way back through the fuselage to a huge turbine mounted near the tail. There, the gases spun a wheel that compressed incoming air, which was then cooled, sent forward again, and rammed back into the engine. It was a massive, intricate cycle of heat, air, and steel. It looked too complicated to work in combat conditions. But it did brilliantly. When German test pilots flew the captured P-47, they discovered that its high-altitude performance was astonishing. Above 25,000 feet, where Luftwaffe engines began to gas for oxygen, the Thunderbolt was still full of life. Its turbo-supercharger kept feeding power long after their own fighters started wheezing. That's when the Germans realized something chilling. This machine could dominate the upper skies for as long as it had fuel. But altitude wasn't the only surprise. The Thunderbolt's dive performance became the next revelation. In test dives, the German pilots noticed that even when they pushed the aircraft toward near-transonic speeds where control surfaces often froze, the Jug held together. Where a Bf-109's wings might flutter or a Focke-Wulf 190 risked losing control, the P-47 cut through the air like a steel spear. The engineers studied its structure again. They found that Republic had reinforced the wings with heavy spars, almost overbuilt compared to their standards. The thick, elliptical cross-section of the fuselage and the sturdy tailplane gave it tremendous strength. The Americans had built it to survive the kind of stress no pilot should ever endure, and that's exactly what allowed it to dive faster than almost any fighter in the war. One German engineer wrote in a report, "The American fighter is not elegant, but it is indestructible," and that indestructibility was exactly what the Allies needed. While the Luftwaffe focused on agility and precision, the Americans built an air force that could take damage and keep fighting. It reflected their entire industrial philosophy. Don't build a perfect machine, build the unstoppable one. The German technicians were further stunned by the Thunderbolt's internal systems. Its electrical wiring was laid out with extraordinary redundancy. Multiple hydraulic systems meant that if one line was damaged, another could still control the flaps or landing gear. The radio suite was far superior to anything in a German cockpit, offering crystal-clear communication even at long range. But what really impressed them was how simple it all was to maintain. Every panel, every component seemed designed to be replaced in the field. You didn't need master engineers. You just needed mechanics with tools. That's how the Americans could keep so many Thunderbolts flying in Europe, even after brutal missions. Meanwhile, the Germans were struggling. Their high-performance engines required delicate tuning, frequent maintenance, and rare materials like high-grade aluminum and magnesium alloys. The Thunderbolt, on the other hand, was built from whatever could take punishment: thick aluminum, steel, and endless horsepower. One of the German analysts noted something that stuck with historians for decades. The Americans build airplanes the way they build tractors, simple, strong, and eternal. And yet, it wasn't all brute strength. The Thunderbolt carried some clever design features that even the Germans grudgingly admired. The bubble canopy on later models, for instance, gave the pilot a 360-degree view, something most German fighters lacked until very late in the war. The control layout was ergonomic and intuitive, designed for pilots to manage everything while under stress. Then there were the weapons. 8.50 caliber Browning M2S. To the Germans, this seemed excessive, until they saw the results. The combined firepower was devastating. Even the armored FW-190s couldn't withstand prolonged bursts. During the tests, engineers calculated the destructive potential of a full salvo. It was enough to tear apart a train car in seconds or slice a bomber wing clean off. No wonder German pilots feared the Jug. They called it the butcher's bird and the flying bulldozer when they saw it diving toward them, spewing tracers like molten rain. Even the most experienced Luftwaffe aces knew they had seconds to react, or none at all. And then there was the psychology of it all. The Germans, for all their technological pride, were unnerved by the Thunderbolt's sheer audacity. It didn't care about rules. It didn't obey the laws of what a fighter should look like. It was a symbol of America's industrial and mechanical confidence, loud, heavy, and fearless. Captured reports from Rechlin revealed the tone of their surprise. They wrote that while the Thunderbolt lacked refinement, it achieved something more dangerous. It could keep flying and fighting under conditions that would destroy most other aircraft. By late 1944, German intelligence officers were spreading the word. The P-47 wasn't just a fighter, it was a flying fortress. And every squadron that faced it knew that once a Thunderbolt dove, you couldn't outdive it. You could only pray it missed. There were also practical lessons. German engineers took notes on the turbo-supercharger, the armor layout, and even the rugged landing gear, which could handle rough fields and absorb brutal impacts. But what they couldn't replicate was the American production power behind it all. The Allies were building hundreds of Thunderbolts each month. Even if Germany had wanted to imitate the design, they lacked the materials, the fuel, and the factories to make it happen. The P-47 was more than just an aircraft. It was a statement. a statement that America could outbuild, out-engineer, and outlast anything the Reich threw at it. And as the engineers finished their tests, many of them quietly admitted something they would never put on paper. They had never seen power like it before. The Thunderbolt wasn't elegant, but it was a monster that worked. It embodied a different kind of genius, one built on simplicity, scale, and raw force. And soon, that force would help crush the Luftwaffe from the skies, leading to one of the most decisive air campaigns of the entire war. But what the Germans didn't know yet was that the Thunderbolt still had one more evolution coming, one that would make it even deadlier, even faster, and practically untouchable. The Jug was about to unleash its full fury. By early 1945, the sky over Europe belonged to the Allies. But for the men who fought beneath the clouds, the roar of a P-47 Thunderbolt diving overhead was still something that froze the blood. Not in fear, but in awe. The Germans had long since realized they couldn't outmatch it. Their engineers had dissected it, studied it, and even admired it, but they couldn't replicate what made it special. And as the war dragged on, the Thunderbolt only grew stronger. New variants, like the P-47D and the ultimate P-47M, pushed the limits even further. With refined turbo-superchargers and massive 2,800 horsepower engines, the Thunderbolt began touching speeds above 470 miles per hour, a staggering figure for a plane that weighed nearly twice as much as a Bf-109. To German pilots who had seen their peers cut to ribbons by .50 caliber fire, the very sound of that deep-throated radial engine had become the sound of doom. By now, the Thunderbolt wasn't just an escort or a fighter. It was a flying arsenal. It carried bombs, rockets, and napalm. It hunted trains, convoys, tanks, anything that moved. In the skies over France, Belgium, and Germany, its presence was constant. When Allied ground forces advanced, P-47s were right above them, flattening resistance, strafing retreating columns, smashing bridges. The German frontline soldiers began calling them Der Jäger mit den 8 Kanonen, the fighter with 8 guns. Even the mighty Tiger tanks, those symbols of German engineering perfection, learned to fear the Jug. Because while a Thunderbolt couldn't pierce a Tiger's armor from the front, its rockets and bombs could rip through its thinner top plating. Entire armor divisions reported being decimated by Thunderbolt strikes. The Allies had built an air war around a philosophy the Germans had never understood. It's not about perfection, it's about dominance. The Luftwaffe, by contrast, was falling apart. Its pilots were young and inexperienced. Its fuel reserves were dwindling. Its once feared Me-262 jets were too few to make a difference. Meanwhile, American pilots were flying Thunderbolts that could absorb half a dozen cannon hits, dive through flak, and still bring their pilots home. And this is where the story comes full circle. In one of the final technical assessments done by captured German engineers after the war, a line stood out, simple but powerful. It read, "The Republic P-47 is a triumph of power over elegance." Those same engineers, who had once laughed at its size, came to respect it as a masterpiece of a different kind. It wasn't a find like their Messerschmitts or beautifully balanced like the Spitfire, but it was effective, devastatingly effective. They admired the way its radial engine could take hits and keep turning. They marveled at its ability to dive without tearing itself apart. They couldn't believe the redundancy in its systems, how, even crippled, it could still fly, still fight, still land. In a sense, the P-47 represented the industrial soul of America, massive, durable, and endlessly powerful. It was a machine born not in the pursuit of elegance, but survival. And that survival instinct, that relentless practicality, became one of the cornerstones of victory in World War II. The statistics tell the story. By the end of the war, more than 15,000 Thunderbolts had been built, more than any other U.S. fighter in history. They flew over 500,000 sorties. They destroyed 86,000 enemy vehicles, 9,000 locomotives, and 6,000 armored fighting vehicles. Thousands of German aircraft were lost to its guns and rockets. But the numbers alone can't capture what the Thunderbolt really meant. To the men who flew it, it was a guardian angel, one that could take them deep into enemy territory and bring them back alive. Pilots often told stories that bordered on unbelievable. One P-47 returned from a mission with its right wing nearly shredded by flak. but it still landed safely. Another limped home after losing a cylinder bank, its engine coughing smoke, yet it kept running. Some even flew back with entire sections of the tail missing, or holes so large you could see daylight through the fuselage. In the words of one pilot, "If you're flying a Thunderbolt, you don't worry about getting hit. You worry about running out of ammo." Even after the war ended, the P-47 continued to serve in Korea, in South America, in post-war European air forces, and in every theater, it earned the same respect. But perhaps the most powerful legacy of the Thunderbolt wasn't in its victories. It was in what it symbolized. It proved that brute strength, when combined with reliability and smart engineering, could outperform elegance and complexity. It was a physical embodiment of a nation's industrial might, a country that could mass-produce not only planes, but pilots, fuel, ammunition, and everything needed to keep the war machine turning. When the captured Thunderbolt sat in that German hangar, surrounded by men who had built the finest fighters in Europe, it wasn't just an airplane they were studying. It was a mirror. In its oversized frame, they saw everything they lacked: resources, production capacity, and the freedom to build without fear of shortage or failure. That's why, when they finally put their tools down and stepped back from the disassembled Jug, one engineer is said to have whispered, "Now we understand how they win." And indeed, they were right. Because the Thunderbolt wasn't designed to be beautiful. It was designed to endure, to outlast, to overpower. It was a weapon of overwhelming force, built not for duels in the sky, but for the total domination of the air war. The Germans had taken apart, studied every bolt and wire, yet what they couldn't capture, what they could never copy, was its spirit. The spirit of a machine built by a nation that believed in power through persistence. In the end, the Thunderbolt stood as both a machine and a message, a symbol of industrial confidence, of American determination, and of the simple truth that in war, it's not the sleekest or the most elegant design that wins. It's the one that refuses to break. And when the dust of World War II finally settled, there were few sounds more unforgettable than that deep, rolling roar of the P-47's radial engine echoing across the battered skies of Europe, a sound that even German engineers, once its fiercest critics, would remember forever: the sound of thunder